Hello, and welcome back. In this video, we're going to review how to calculate the molar mass of a compound. We're going to start with easier questions and work our way towards more difficult ones. Now, before we can even think about calculating the molar mass, we need to understand what the molar mass is. So, on your periodic table, it looks something like this, but is not necessarily arranged the same. You're going to have a number underneath your element, in this case hydrogen 1.008. That represents both the atomic mass, the mass of an atom in atomic mass units, and that also represents the mass of 1 mole of those atoms in grams. So we are going to take this number and put grams behind it to talk about molar mass. Okay, so let's start with water. For water, as I just discussed, my hydrogen weighs 1.008 grams per mole, and oxygen is going to weigh 16. Now, one thing you have to notice is that the hydrogen has a 2 next to it. That subscript tells me that I have 2 hydrogens. So I'm going to multiply by 2. Now, I'm going to take these numbers and I am going to add them together. Which gives me a molar mass of 18.016. Let's try another one with CH4 or methane. Now, carbon has a mass of 12.01 grams per mole. And as we've already talked about, hydrogen has a mass of 1.008. Our hydrogen, again, has a subscript, so we multiply. If 1 hydrogen weighs 1, then 4 hydrogens weighs 4 times that, right? So that gives me 4.032. And I'm going to add those 2 numbers together. So that gives me 16.042. All right, let's look at NH3. Nitrogen has a mass of 14.01. Again, with hydrogen, 1.008. Hydrogen gets multiplied by 3. And then I add those 2 numbers together. For a molar mass of 17.034. Now, I have not written this on the previous questions, but our unit for this is going to be grams. All right, let's get to one that's a little bit harder. All right, sodium sulfate. Here I've got 3 atoms instead of 2, and 2 subscripts instead of 1. So we'll start with getting our masses off of the periodic table. 22.99 for sodium, 32.07 for sulfur, and 16 for oxygen. My sodium gets multiplied by 2, and my oxygen gets multiplied by 4. Now, I have previously done each individual piece, but what we can do is throw some parentheses around these things and add them together like that, and we can type it all in at one time into the calculator. So what I get is 22.99 times 2 plus 32.07 plus 16.00 times 4, which gives me a molar mass of 142.05. Let each element get a set of parentheses. All right, and then the final, and in my opinion, most complicated question, we're going to do calcium phosphate. So you'll notice here that we have a set of parentheses. I'll explain that in just a minute. First step, just like in the previous question, we're going to pull the molar masses for each element off the periodic table. 40.08 for calcium, 30.97 for phosphorus, and 16.00 for oxygen. All right, just like in the previous questions, when I have a subscript on an element, I'm going to multiply. So my calcium gets multiplied by 3, and my oxygen gets multiplied by 4. Now you'll notice that we haven't done anything with that 2 yet. We're going to do that now. So this 2 gets multiplied for the entire set of parentheses. Just like in algebra, if I have a 2 on the outside of a set of parentheses like this, that 2 gets distributed throughout that entire set of parentheses. We're going to do that here. So my 2 gets multiplied by my oxygen, and my 2 gets multiplied by my phosphorus, times 2 times 2. Now, until you get comfortable, what I would recommend to you is, I know it looks ridiculous, but leave it as 16 times 4 times 2, so that when you go back and look at your questions, you can see where these numbers came from. Because if I were to write 16 times 8, and I didn't understand what I was doing, I would look back at my formula. Well, there's no 8 in the formula for calcium phosphate, so I might get confused about where that is. So I would keep it together. So again, each element gets its own set of parentheses, and we add them together. So 40.08 times 3 plus 30.97 times 2 plus 16 times 4 times 2, which gives me a molar mass of 310.18 grams. That's it. That's how you calculate molar mass.